Okay, let's have a look at question 5 then. What have we got? Consider the curve y equals 1 plus 1 over 2x, where x cannot equal 0. First thing I'm probably going to do when I approach this question is to just plug that into the GDC and see what comes out. And here's what I get. Right, here it is. So my GDC comes out with this. Just double check, always worth checking, that what I've got here is the same as what was in the question. So I'm kind of ignoring the domain restriction, and that looks absolutely fine. So we've got the general idea of the shape. So what's it asking us? The value of the x-intercept. Where does it cross the x-axis? That's here. And also the equation of the vertical asymptote, which is, we can see quite clearly, runs along there. So the x-intercept, we know from our working class that the x-intercept is at y equals 0. So we want this at y equals 0. And so we want, instead of y, 0 now equals 1 plus 1 over 2x. Minus 1 equals 1 over 2x. Multiply by x, we get minus x equals a half. Multiplied by minus 1, we get x equals minus a half. Let's look at that in relation to our graph over here. That kind of makes a whole lot of sense. Minus a half, I'm happy with that as an answer. So that's my answer for part 1. Underline the final answer. Let's go for part 2 now. The equation of the vertical asymptote. Well, I can kind of see where it is looking at my GDC. I've marked it on there in red. I'm just going over it now in blue. I'll undo that so we can still see it in red. We can see that it's on that y-axis, but we know that vertical asymptotes are, if we've got a fraction, they occur at the point that would require us to divide by 0. We can't divide by 0, so we want that denominator to equal 0. So what do we have? 2x equals 0, divide by 2, x equals 0. Oh, 2! Gosh, don't do that. X equals 0. And so we've got that, and that describes perfectly the y-axis that we're after, and so I feel that I've got a lot of confidence in my answer when I relate it to the GDC and what we've been given. Let's rub this out here. We've got a lot going on here. Yeah, let's rub it all out. Okay, and we'll move on to part 2. I want to take... oh no, I have to take that. Hang on. Okay, I'm on my way now to the second part. And part B asks us to sketch for the curve between minus 2 and 4. Well, that's made my life a lot easier. I've got it on the GDC. We just need to make sure we include all the important information. So this sketch should look like this. Let's stay in blue. We've got a shape coming down here. We need to ensure it goes through minus a half that we've just worked out, and it comes down here and goes along. So we need to make sure we label all the important points. We've got this point here. It's going through minus a half, and I'd write that on there explicitly so it's following through from what we had previously. We've got this vertical asymptote here, which I think is nice to write on, and that's at x equals 0. And we just need to think about our horizontal asymptote. Now, I've drawn it here quite accurately, but I should have done the workings first. Let's do the workings and just check where that is. Now, the workings for this, there are a number of ways of doing this. Thinking about graph transformations is probably how I would do it. We know that 1 over 2x has a horizontal asymptote at 0, and so we're just shifting it up by 1, so we're adding 1. That's probably in my thought process. The reality is, what we're probably going to do though, is we're going to observe it here at 1, and we are going to use our table function in our GDC in order to just see what happens when it gets very large, or put in a really large number and see what it's close to. So sub in x is 1,000, we get 1 plus 1 over 2,000, and that comes out at a number very close to 1. In fact, when I plug that in, it comes out as 1.0005, and we can see it's close to 1, it's tending towards 1, and so that gives us a bit of confidence in this answer that this asymptote is at y equals 1. And there we are.